So here I'll be explaining how to do the introductory worksheet on half-life. Now the explanation I'm going to be giving for these questions is not going to make any sense unless you've taken the notes and done the notes first, including the practice problem on the notes. So that's the first thing you should be doing before you watch this. But anyways, here we go. So number one, what is meant by half-life? That is the time it takes for 50% of a sample of something to decay. So let's start with number two. Number two, if you have 100 grams of a radioactive isotope with a half-life of 10 years, how much of the isotope will you have left after 10 years? So that 10 years is the half-life, so you're going to have half of 100, and that's going to be 50 grams. How much of the isotope will you have after 20 years? So in this case, after 10 years, we have 50 grams, and 20 years is another half-life, so another half-life has passed, so now we're down to 25 grams. How many half-lives will you have in how many half-lives will occur in 40 years? So it's not asking how much of the isotope you're going to have left, it's going to say how many half-lives. So if each half-life is 10 years and we got 40 years, that's 4 half-lives. Okay. The half-life of plutonium-239 is 24,300 years. If a nuclear bomb released 8 kilograms of this isotope, how many years will pass before the amount is reduced to 1 kilogram? Okay, so the question is really asking how many half-lives have occurred for 8 kilograms to decay to 1, right? So let's just think about this. There's a lot of ways we could do this problem, but I'm just going to do sort of the easiest way to visualize. So if we start with 8, after the first half-life we have 4. After another half-life we have 2. And after another half-life we're down to 1. So how many half-lives have passed? Well, 1 here, then 2 have passed, so 3 total. So 3 half-lives have passed. And if each half-life is 24,300 years, that's just going to be 24,300 times 3, because there's 3 half-lives. And so what is that? That looks like maybe 72,900 years, right? Because 3 half-lives have passed. Okay. So next one. The half-life of radon-222 is 3.8 days. How much of a 100-gram sample is left after 15.2 days? Okay. So the first question we got to ask ourselves is how many half-lives is that? So if we have 15.2 days and each half-life is 3.8 days, what is that? That's 4. So 4 half-lives have passed. So we can just go 100. After the first half-life, it's 50. After the next half-life, it's 25. After the next half-life, it's 12.5. That's only 3 half-lives. So after the next half-life, it looks like it's going to be 6.25 grams are left. So that's how we do that one. Number 5, carbon-14 has a half-life of 5,730 years. If a sample contained 70 milligrams originally, how much is left after 17,190 years? Okay, similar to number 4, we got to figure out how many half-lives that is. So 17,190 divided by 5,730. So how many half-lives is that total? That looks like 3. So 3 half-lives. And this is a basic worksheet, so these numbers are always going to be whole numbers because it's a basic worksheet, right? It gets way more complicated if there's decimals and things like that. So 3 half-lives have passed. So how much is left? Okay, so if we started with 70, after the first half-life, we're down to 35. After the next half-life, we're down to 17.5. And after the third half-life, we are now down to, what is that? Let's say 8.75. Believe that's right. So that's how much we have left. Now let's go to 6. If the half-life of cobalt-60 is 5.26 years, if 50 grams are left after 15.78 years, how many grams were in the original sample? Again, let's kind of figure out how many half-lives have passed here. So 15.78 divided by 5.26, that's going to be 3. So 3 half-lives have passed. So 50 grams are left. So let's kind of work backwards, right? So if 50 were left, prior to that half-life, there was 100. Prior to that half-life, there was 200. And prior to that half-life, there was 400, right? So all I'm doing is sort of reversing time, right? I got the green infinity stone, I'm turning my wrist, and this thing is going backwards. So here you can see this half-life, it's gone through 3 half-lives. The original amount must have been 400. So 400 grams. And that's just basic logic, right? Just work backwards. Number 7. The half-life of I-137 is 8.07 days. If 25 grams are left after 40-some days, how many grams were in the original sample? Again, let's figure out how many half-lives this is. So 40.35 divided by 8.07, that looks like it's 5. So 5 half-lives have passed. So how many grams were in the... So this is going to be similar to the question previously. So let's work backwards. Let's rewind time. So 25 are left, and we got to go back in time 5 half-lives. So previous to that, there was 50. Previous to that, there was 100. Previous to that, there was 200. Previous to that, there was 400. And that's 4 half-lives. Previous to that, there was 800. So that must be 800 grams in the original sample. All right, so that was 5 half-lives. Back in time. Number 8. If 100 grams of gold 198 decayed to 6.25 grams in 10.8 days, what was the half-life? Okay. So we got to figure out, basically, if you start with 100, how many times do you have to divide by half to get to 6.25? And that number of divisions tell us how many half-lives have occurred, and then we could kind of figure that, if there's, the total amount of time is 10 point, we can work it from there. So let's just figure out how many times we have to divide it by 2 to get from 100 to 6.25. So 100, first half-life goes to 50, second half-life goes to 25, next half-life goes to 12.5, and the next half-life goes to 6.25. Okay, so 1, 2, 3, 4. There are 4 half-lives that have passed. If 4 half-lives have passed in 10.8 days, that means that each half-life must have been, oh geez, what is that, 2.7? 2.7 days? Yep. And then the last one is a graphing one, which I will show later. Okay, so I have plotted the points on the last graph and drawn a curve of best fit as best I could. And the question here is trying to figure out the half-life. So how long before half of the sample remains? You can see that if you start with 100, half of that is at 50. So we're really looking for when does the graph cross here. And so the graph hits 50 at approximately, I'm going to say 2.2 years. So 2.2 years would be the half-life, according to my graph.